Hello everybody. Today we're working with Chapter 5, Lesson 1 and 2, where you will be writing linear equations from everyday situations, graphs, and tables. Our TEK 8.5.I tells you to write an equation in the form of y equals mx plus b to model a linear relationship. Remember, linear means a straight line. Also, the processes that we will be using is 8.1a, where we apply this information to everyday situations, that is our real world situations, and 8.1.E, where we will create and use representations to organize, record, and communicate mathematical ideas. So it could be our own ideas. Because 8.5.I said that we will be writing equations in the form of y equals mx plus b to model linear relationships, we know that that is our slope-intercept form. And so that's the equation of a straight line. Again, straight line for us is just linear. That form is y equals mx plus b, where m is the slope that is multiplied by x, and b is the y-intercept. And this is where your line crosses the y-axis. B is also your initial value. Okay, this unit is very important because in many real-world situations, you will not be given an equation to solve. You will be given a problem that will require you to first write the equation and then to solve the equation so that you could have your information. Now, whenever we have a real-world situation, there are two things that we are looking for. The first thing is a rate. So the rate is going to be your slope. That's going to be your m in the problem. And the following are examples of how you know you have a rate. You'll see words like per, and you could even see every. So again, you're looking for those things that are telling you about the unit rate or giving you some type of unit rate. This number is always going to be related to the x value. So you will always take that rate and multiply it times x. The next thing we're looking for is a flat fee. Your flat fee can be thought of as your initial value. And that is going to be your B. So in your problem situation, as far as your equation, your initial value or your flat fee or your startup information is going to be your B. This value is constant and it never changes. So another word I want you to write is anything that you begin with. So let's write startup. So anything that you start up with or that you begin with is going to be your initial value. Okay, so let's begin with some real world situations. In example 1, in order to become a member at a local gym, there's a $50 startup fee, then a $20 fee every month. We need to write an equation for the situation where C, the total cost, is a function of G, the number of months spent at the gym. So remember, we are writing in the form of y equals mx plus b. Now let's go through and identify some information. We know that there is a $50 startup fee, so we know that $50 will be our B. Then a $20 fee every month. That is going to be the M is going to be our unit or our slope or our unit rate. Now let's write our equation. They told us to write the equation for this situation where C is the total cost. Remember, in y equals mx plus b, y is your total cost. So in this case, we're going to put C equals m is your rate. So we have $20 times x. But we're not going to use x because they told us is a function of g. And so g is the number of months spent at the gym, which that could change. It could be 1 month, 2 months, 3 months. So you're thinking about your x. X is the number that changes. In this case, we're going to use G plus our initial fee, which is $50. This is your equation. So hopefully you just said That was so easy because really it will get easier as you continue to write these. Let's move on to example 2. For babysitting, Nicole charges a flat fee of $3 plus $5 per hour. We need to write an equation for the cost C after H hours of babysitting. So let's go back and look at our information. We know Nicole charges a flat fee of $3. So flat fee of $3 will be my B, plus $5 per hour. This is my rate, so that would be my M. We need to write an equation for the cost C. So Y is our total and C is what we will use instead of Y. M is my rate. My rate is $5 per hour, which we are going to use H for X. X changes based upon our situation, and in this case, H changes based upon the number of hours that Nicole babysits, plus 3, which is the initial amount, and that amount never changes. That is our equation there for number 2. Now for number 3, I am going to use a table, so I would like for you to use one as well. I'm going to use a table to help organize my information. Now, when I am writing in an equation, remember in the form of y equals mx plus b, I know that m is going to be my rate, and b is going to be what stays the same. So now I'm going to look back at my situation. It said a plumber charges $25 for a service call. So $25 for a service call. That amount does not change. No matter what, he is going to charge $25 for the service call. So that stays the same. So I'm going to write $25 there. Plus $50 per hour of service. That is my rate. That is the amount that changes based upon the number of hours that he is there. It could be $50 for 1 hour. It could be $100 for 2 hours. Whatever the case, that is my rate. So that would be my slope. Now I'm just going to put the information in. It said write an equation for the cost C. So C is my total, which is Y. M would be replaced with 50 times X, but X they told us to use H hours, so what's going to change, instead of us using X, we're going to use H because the hours will change, plus $25, which is my initial cost. No matter what, have to pay that $25. That is the equation for that problem situation. All right, turn the page over. We're going to stop the video here. I would like for you to work problems 4 and 5. Then we will restart the video to see if you got the right information. All right, a water tank already contains 55 gallons of water when Baxter begins to fill it. Water flows into the tank at a rate of 8 gallons per minute. We need to write a linear equation to model this situation. I know that the tank already contains 55 gallons. That is my B. That's my initial value. It doesn't change no matter what. There was 55 gallons of water already in that tank. It flows into the tank at a rate of 8 gallons per minute. I know this would be my M because that is my rate. I have Y is equal to 8 times X plus 55. That is my equation that models this situation. Let's move on to number 5. The cash register subtracts $2.50 from a $25 Coffee Cafe gift card for every medium coffee the customer buys. Need to write an equation to represent this situation. Okay, so I'm going back and looking. I know that it subtracts $2.50 for every medium coffee the customer buys. Then I have a $25 coffee gift card. Now, I'm thinking about the information and where would it fit in my equation y equals mx plus b? Well, b, I know has to be the amount that stays the same, or that is my initial value. I began with $25 on that card. Okay, so the coffee cafe gift card had $25 to begin with. Now, my rate is going to be my M, and I'm thinking about what's changing. What was changing is it's going to subtract $2.50 for every cup of coffee that is bought. If I were to graph this just to organize my information, I know that I begin with $25. And for every cup of coffee bought, the amount of money on my card is going to decrease. It's going to go down. So now when I'm writing my equation, I know y equals negative $2.50 times x plus 25 is my equation. And it makes sense because if I buy 1 cup of coffee, it's going to be a certain price left on my card. If I buy 2 cups of coffee, 3 cups of coffee, 4 cups of coffee, and so on, the amount on my card is going to continue to decrease. So that means I have a negative slope, and when I look here, I have a negative slope. Okay, now let's look at graphs. So with graphs, we need to find the y-intercept, and remember the y-intercept is going to be where x is 0 and b is going to be our y value. And our y value will always have some type of a number. Okay, so now I'm going to look at the first graph I have. And when I look right there at that location, I see that the line crosses the y-axis at 0, 4. That means x is 0 and b or y is 4. So b is equal to 4. That's step 1. Step 2 says I need to identify the slope. And so slope can be found as rise over run. That means I'm going to go up or down first, then I'm going to go to the left or to the right. So I'm going to find another point on my line, and I see this point there. Now, to get from this point, I have to go up 2, so up 2, which is plus 2 over 1, plus 1. So my rise, I went up 2, then I went to the right 1. M is equal to 2. My equation for this line is y equals 2 times x plus 4. Remember previously we talked about identifying certain things. I can identify that my slope is correct because if I look at the line, my line is increasing from left to right, which means I have a positive slope. And if I look at my 2, it is a positive 2. Now let's move to the next one. On the next one, I have a point there, which is where the line is crossing the y-axis. That location is 0, 4. So that means x is 0 and y is 4. That fits what I said for step 1. So b will be equal to 4. Now I need to find my slope. So I'm going to find another point that is on that line. If I look there, I have a point right there that where it crosses x and y. Now I'm going to think about how do I get to that point? Well, I have to go from the y-intercept. I would have to go down 1, which means I negative 1, and then I went over 2, so plus 2. That means my slope is negative 1 over 2. My formula would be y is equal to negative 1 over 2 times x plus 4. That would be my equation written in the y-intercept. Written in the slope-intercept form. Now, let's talk about tables. For tables, we need to find the change in y over the change in x, and this is going to be your slope. So remember, To find slope, that just meant y2 minus y1 over x2 minus x1. So let's replace or put in some numbers for our values. So we're going to put in 26 for y2, and let's put in 14 for y1. Let's put in 2 for x2. Let's put in 1 for x1. Now we just subtract, so we have 12 over 1, which is 12. So that means my slope, m, is equal to 12. Now, I could also chosen the values 38 minus 26 and 3 minus 2, which would be 12 over 1, which would be 12. And I still got the same information. Now, in my formula, I have y equals 12 times x plus. Now, let's look at this. If I look, I don't have 0. And remember, my b has to be where my y-intercept is 0. And I'm sorry, where the x is 0 and my y has a value. So I can quickly get to my y value by saying y equals 12 and replacing x with a number that was given. So for example, I'm going to put in the number 1 because that's the first x that I have. So the first x I have is the number 1. When I say y is equal to 12 times 1, which is 12, that's okay. But when I look at the y value for 1, I have 14. I just ask myself, well, how do I get from 12 to 14? It is plus 2. That would be my equation for that graph. Now, I want you to go ahead and work the second one on your own, then start the video back to see if you have it correct. Okay, so the first thing I need to do with a table is find the change in y over the change in x so I can get my slope. So m is equal to y2 minus y1 over x2 minus x1. I'm going to replace or put in 160 for for y2. And then I'm going to put in 140 for y1. Then I'm going to put the number 2 in for x2 and the number 1 in for x1. I'm going to subtract, and when I do, I get 20 over 1, which means that my slope is equal to 20. So when I'm writing my equation, I can go ahead and put y equals 20 times x. Now, if I just work this out, just what I have so far, y equals 20 times x. And I put y equals 20, replace x with the number 1. When I replace x with the number 1, that is not what I get. I get 20. I don't get 140. Now I ask myself, well, how do I get from 20 to 140? Well, I need to add 120. That is my equation for that table. Let us know if you have any questions. You guys have a great day.